All right, good afternoon. Welcome to class 3. We are doing section 0.2 complex numbers. Now I wanted to talk to you a little bit about complex numbers. Many people look at them and they're like, why do we need a new number? Why imaginary numbers? Because that's what this unit is. It's called an imaginary unit, I. Why do we deal with imaginary numbers when we have the ability to just use real numbers? I mean, math can be hard enough. Why add to it? Well, as you go forward into calculus and stuff, you will find that this is a very common occurrence. We can find occurrences of this kind of root in nature. And it's very interesting how functional this root is and how it actually changes all of mathematics. Because the complex numbers, all real numbers, are actually in the complex plane. So a complex number, we'll get to this more as we work out, but complex number is always written in the form a plus ib. Usually it's written bi. I like writing it bi. A plus bi. This is the complex imaginary part, and this is a real number. It's always written in this form. You will find over and over that you will have a plus bi. That means every real number you know, like if I were to say 3 is a real number, you're used to it. Well, this simply means plus 0i. It is still a complex number. The two intersect, and you're used to using half of them. But this other half can get very interesting. These numbers are always there. You've been working with them. This is another plus 0 that mathematicians have, but we hide it because we're lazy and we don't want to write it. For you guys that have been in my class, you know that I say mathematicians are very lazy. So, what we're going to start out with is I have defined here what the imaginary unit I means. I is the square root of -1. How am I going to look at the powers of I? Because as we go through this, we're going to have to deal with powers. And whenever you have a square root, we're trying to do that. So let's look at some powers of I. If I have I to the 1, well, this is very easy. This is square root of -1. That's the definition. But what if I do I squared? Now I have the square root of -1 squared. That is going to become -1. This is how we can end up with the square roots of every negative number. The roots of a negative number, they don't have real roots. They now have imaginary roots. And so we still can use the square root function. We just have to go into a different plane, the complex plane. Now, I cubed. This is the square root of -1 cubed. Well, I can rewrite this as the square root of -1 squared times the square root of -1. Well, as I'm looking at this, I already know what the square root of -1 is. So I can say that this will be -1 times the square root of -1. Now, mathematicians are lazy, so I'm going to leave the negative sign and drop this 1. Also, we know this. This is the definition. So this will be -I. It's very interesting how this will cycle back. We are going to end up with a pattern. Now, in the future, I'm going to continue this pattern so that we can see it. But I want to show you guys using I now. Know that I is square root of -1. So if I have I to the 5th power, well, I know I to the 4 is 1. So I'm going to say that this is I to the 4 times I. This just becomes 1, so then I simply end with I. If I have I to the 6, well, this is I to the 4 times I squared. Well, I know I to the 4 is 1, and I squared is -1, so I'm going to get 1 times -1, which is -1. I to the 7 equals I to the 4 times, now I'm going to rewrite the last 3 as a square and an I squared I. This becomes 1, this is -1, and this is just I. So then I can say that it's 1 times -1 times I, which will give me -I. And then I to the 8 is I to the 4 times I to the 4, which equals 1 times 1, which is 1. Now you will see here a pattern. You have I, -1, I, 1, I, -1, I, 1. This pattern becomes very important when we're solving higher orders of I, higher powers. So what if I had a problem and I said that I need to find I to the 59? Well, 59 is very big and I don't want to have to expand it like this. So I am going to use my rule here that every I to the power 4 will give me 1. So then I can say 59 and divide it by 4. So 59, I'm going to divide it by 4 to find out how many 4s will actually fit into 59. 4 goes into 5 one time, leaving 1 left over. So then I'd have a 19. 4 goes into 19 4 times, leaving 3. So I'd have remainder 3. You can check this in your calculator. The answer you should get is 14, remainder 3. So that means I could rewrite this problem. Rewriting this problem, I can say I to the 4, and there's 14 of these. And then I'd have I power 3. Okay? So this 14, all of these become 1. So now I just have to deal with power 3. So then this is I squared times I, which is -I. This works every time, and it's very simple to find out how many power 4s are here. And then take out the remainder. The remainder will tell you what you have. All right. So now that you have the complex numbers and you know that we need to write them in the form a plus bi, this will become important when we use these different operations on the complex numbers. So we can have complex numbers and we can add them and subtract them, multiply and divide, just like what you guys are used to in other maths. But now we're going to have to use I, and when we multiply, because there's 2 units, we're going to end up having to use the FOIL method every time we multiply 2 of these numbers. So let's do an example in each one, and then I will work some sample problems with you. So our first example for addition, let's try 4 minus 3i plus -2 minus 2i. There we go. First thing I'm going to do is put my real parts together and put my imaginary parts together. Notice I'm going to end with a number where there's real and imaginary. So as I work through this, I'm going to put my 4 and -2 together. So 4 plus a -2. Then I'm going to group my i's together. Plus negative 3i minus 2i. Okay? Now, the signs, remember to keep them in front of the number that you're working with. We don't want this negative 2 or minus 2i to become a positive 2 over here. All right, now that I have them grouped together, I will simplify the real part and then simplify the imaginary part. So 4 take away 2 will give me 2. 3i take away 2i, well, realize they're both negative, will give me a negative 5i. This will be my answer. You would do a similar thing with subtraction. Just remember that if you had a minus sign here, this negative has to distribute. It is more interesting to look at multiplication and division. So I'm going to try and multiply these two. So to multiply them, I would get 4 minus 3i times negative 2 minus 2i. Now, to FOIL, I'm going to do the first, outside, inside, last. So my first terms will give me a negative 8, outside terms, negative 8i, inside terms, positive 6i, last terms will give me plus 6i squared. Now, I already know that this can become negative 1. So this last term will actually end up being a real term. So this will become negative 8. I'm going to combine these imaginary terms here. This is negative 8 plus 6, so I'm going to have negative 2i. And then this is a negative 1. Remember, this will always be negative 1. So negative 1 times 6 means I'm going to subtract 6. So negative 8, take away 6 more. I'm going to have negative 14 minus 2i as my answer. And now to divide. I'm going to put this term on top and divide by this term. So negative 2 minus 2i divide by 4 minus 3i. Now, this division is a little bit more complicated because it's just like dividing in the real numbers when you have addition and subtraction. I can't just straight out and say, oh, I can take this and make this 2 and make this 1. No, I can't do that because there's addition and subtraction. So I have to find some way to rationalize this. It's kind of like when you guys first used the square roots. Remember how you learned the rule that a square root cannot remain in the denominator of a fraction? We like to say the same thing about the imaginary unit. I cannot keep the imaginary unit in the denominator. So to divide this, I am simply going to remove the imaginary unit from the denominator and move it to the numerator. To do this, I am going to multiply by what is called the conjugate. The conjugate is the exact same real part and the exact same imaginary part with the opposite sign. So I'm going to multiply this by 4 plus 3i and 4 plus 3i. Now, this would cancel because it's the exact same on top and bottom. So this is simply multiplying by 1. I have not changed my number. I am multiplying by 1. Okay? And any number times 1 will give me my same number back. So, now let's multiply. We have to FOIL twice now. So, negative 2 times 4. Fortunately, we already know what this is because I just did it here. And the order doesn't change my answer. So I'm going to have, this is still going to be negative 8, and 2 times 3i is still going to be positive 6i. Well, sorry, we do have to do this because we changed the sign. Okay, so negative 8 minus 6i minus 8i minus 6i squared all over. So it's similar, but because we did change the sign, we don't know what it is. On the bottom, 4 times 4 is 16. 4 times 3 is positive 12i. Negative 3 times 4, minus 12i. Negative 3i times positive 3i is negative 9i squared. Now, one way that you actually know that you used the conjugate correctly is if these terms cancel. If they don't cancel, something went wrong. My imaginary unit should disappear. So I now have on top negative 8 minus 14i. This is a negative 1. Negative 1 times negative 6 will give me positive 6 all over 16, and then negative 9 times negative 1 will give me plus 9. So now I can add here and I get 2 minus 14i divided by 25. Now, I would like to say I was done there, but I can't. Remember the form that we have to write this in? We have to have the real part and an imaginary part, but here it's all one. So I am not done with this yet. I have to simplify. So this is where I had my answer, but now I gotta write it in the proper way. So I have 2 minus 14i over 25. Now I can use this subtraction on top, so I can divide this by 25 and divide this by 25. So I will get 2 over 25 minus 14 over 25 I. Okay, now I have my real part and my imaginary part of my complex number. And then the last step is to make sure that these fractions are simplified. And nothing will divide this, nothing will divide this. So my fractions are simplified. Are you ready to work some problems? I have written here some sample problems that we are going to solve together. These problems can help you practice, and if you would like, you can pause the video, work ahead of me so that you can find what these problems would be, and then you can come and check with me and see the answers and see how I worked them. So go ahead and take a minute either between the different problems or after or here to finish the problems on the page. All right, so I'm going to start by solving this one. I've got I to the negative 10. This is not going to be as nice as I had hoped because now I have the negative. So I'm going to have to think back. What does that negative exponent mean? Now, if you're not remembering what to do with the negatives, talk to me about it and we can go over how the negative sign will flip a fraction. What this is saying is I have 1 on top and I to the 10 in the denominator. So now I'm ready to work through this problem. Using I to the 10, I can divide 10 by 4 and I'd get 2, remainder 2. So I know I'm going to have I to the 4 twice and a remainder 2. This means or implies, this symbol, the equals with the arrow, means implies that I have I over, or 1 over I to the 4 times I, when my hand wants to write 5 and I need to write I to the 4 times I to the 2. Using my powers before, I know this is 1, and this is negative 1. So 1 times negative 1 would give me 1 over negative 1, which would simply be negative 1. That's my answer. I to the 77. Again, I need to find out how many times does 4 go into 77. So, dividing 77 by 4. 4 goes into 7 one time, leaving 3. Then 4 goes into 37 because this would leave 3 on here. So 4 goes into 37 9 times. And then I would have a remainder of 1. So I know that I have I to the 4 remain with a I multiplied. So I to the 4 19 times and then 1 I left over. So this is the same as saying 1 to the 19 times I. Well, 1 to any power is still 1. So the answer here is I. Here I'm now adding these, and so I find out what this one will become and what this one will become and then add them. Well, I to the 4 is very simple. This is simply going to be 1 plus. Now, this is a multiple of 4. So I know that that's some number times 4. So I can write it as I to the 4, and then that some number will be 3, because 12 is 3 times 4. So this is 1 to the 3rd power. So I have 1 plus 1, which is 2. Yes, these are some complicated ways that you can write some very simple numbers. All right, I to the 5. I to the 5 is not a power of 4, but I have 1 4 here. This is I to the 4 times I. Plus, now 4 will go into 9 2 times. So that means I have I to the power 4, and it went in 2 times. 2 times 4 is 8, so that leaves me 1 I left over. So now these become 1, and these become 1, and I have I plus I, which gives me 2I. Finally, over here, I have I to the 3 and I to the 20. Okay? Well, I to the 3, it's a power less than 4. So I know I to the 2 will give me a negative 1. So this is I squared times I plus. Well, 20 is a multiple, or 4 is, 20 is a multiple of 4. 4 is a factor of 20. So I can write this as I to the 4. And then 4 times 5 is what gives me 20. So this is going to be I to the 4 5 times. Well, I have negative 1 times I, that's negative I. And then I to the 4 5 times is still going to be 1, so that's 1. Now, you'd like to be finished there, but remember the order that we have to write in. We have to write it in the form A plus BI. So I need to write it as 1 minus I. All right, ready to do some simple arithmetic with this? The arithmetic problems, the only big thing that we have to watch for is what our I is doing. Let me zoom in a little bit on these as I'm working on them. All right, so I'm going to simplify this problem. I'm going to start by grouping my real and then grouping my imaginary. Now, if you can do this in your head, that's fine. Just be careful when we get to subtraction that you actually change the signs that the negative will force you to do. All right, 7 plus 2. So I can put 7 plus 2, that's my real part. This is a negative 4I minus 3I. 7 plus 2 will give me 9, minus negative 4 minus 3 will give me negative 7I. Okay, over here we have 2 plus 3I plus negative 6 plus I. So in this time, I'm going to show you how you can group in your head. 2, and then I look at this plus negative 6. 2 plus negative 6. Well, that's the same as 2 minus 6, which would give me a negative 4. And then you can look here. Positive 3 plus positive I, this is a 1i, so 3 plus 1 will give me 4, so plus 4i. Remember to make sure that your numbers are in the form a plus bi. Here we have 5 take away or minus negative 5. 5 minus negative 5. Let me rewrite this so that our signs are right. 5 plus 7i. Negative negative gives me a plus 5. Negative positive gives me a minus I. So now I can see that this is 5 plus 5 is 10. And 7i take away 1i is plus 6i. Next problem. Now they're throwing a decimal at me. You can have decimals, you'll have some roots, you'll have all kinds of things that they can put in here. Remember, all real numbers are possible. And B, this number in front of I, like the 4 here, or the 7, or the negative 1 here, the 6 here, the 3 here, all these are also real numbers. So fractions and decimals are all available while we're working these problems. So I have to remember this negative sign can change my 2. So I'm going to change that around for me, keep my sign straight. Plus I minus 2 plus I. All right, so 0.5 take away 2. Well, this is 1/2. And if I had 2 pizzas and I cut them in halves, I'd have 4 halves, and so 1 take away 4 would give me 3 halves. So you could say it as 1/2 take away 3, or take away 4 halves equals 3 halves, and this is 1.5. So I have negative 1.5 plus, because this is positive and this is positive, I plus I is 2I. Now we're ready to do some foiling. Here I'm going to FOIL, and I'm going to do the first, that's 8, the outer plus 6I, the inner plus 4I, and then the last, which is plus 3I squared. Don't forget your squared, that changes things. Now, 8 I'm going to leave because I have to simplify there. 6 and 4, they're both positive, so I'm going to add them, and I'm going to get 10I. And then this is a negative 1. I squared is negative 1. Remember that I equals square root negative 1. So, I squared is negative 1. This is 3 times negative 1. I'm going to have a minus 3. So then my answer is 5 plus 10I. Next problem here. So now I have the exponent. You have to remember what the exponent means. You can't just square this and square this. It means that I have 2 of them that are being multiplied together. This is the same as writing negative 2 minus I times negative 2 minus I. When it's written this way, you can see that I need to FOIL. Be careful, because a common mistake that I have seen is taking the square and putting it on the I and putting it on the 2 and ending up with 4 plus I squared, which would be 4 minus 1, and that would give me 3. That is not the case. You cannot just distribute a square. You can see we have to FOIL. So here, negative 2 times negative 2 is positive 4. Negative 2 times negative I gives me a plus 2I. Negative I times negative 2 gives me a plus 2I. Negative I times negative I gives me a plus I squared. So I now have 4 plus 4i, and then I squared is negative 1 minus 1. That is 3 plus 4i. Now we get to do some of these conjugates. And you can see here I've put some square roots in here. All right, the conjugate for 6 plus I. Remember, I can't have the I in the denominator. That means I have to multiply by the conjugate of the denominator. The conjugate is the different sign. So I'm going to multiply by 6 minus I. 6 minus I. Now I'm going to have to FOIL. So 5 times 6 is 30. 5 times negative I is negative 5I. I times 6 is plus 6I. I times negative I is negative I squared. And in the denominator, we have to FOIL again. 6 times 6 is 36. 6 times negative I is minus 6I. I times 6 is plus 6I. I times negative I will give me a negative I squared. Now, double check yourself. If you did it right, these terms cancel. So I can cancel this one, because I've got a positive 6 and a negative 6i, and so they will cancel out, give me 0i. And this is a negative negative 1, so on the bottom I'm going to get 36 minus negative, which gives me plus 1. On the top, I'm going to get 30. Negative 5 plus 6 gives me a plus I. Negative negative 1 gives me a plus 1. So now I can rewrite this as 31 plus I over 37. Now you are not done yet. To be finished, I have to have it in the form A plus BI. This is not in the proper form, so I have to write it as 31 over 37 plus 1 over 37 I. Now, it is your choice. You could put the I on top of the fraction. That is the same answer. But I like to write it this way so that you can see this is A, this is B, and there's my I. Final problem, and then I'll let you guys go and do the homework. All right, here I have to do the conjugate, but I got roots in here. I've got all kinds of things. I'm going to have to remember several of my tricks using square roots and factoring and foiling using these different terms in order to solve this problem. So this is like the pinnacle of kinds of problems you might see, at least right now, because this will make sure that you understand your square roots, that you understand how to multiply binomials, that you know how to do all these things. And as we'll go through this problem, you will see how this problem will test you on these. So first, I'm going to multiply by the conjugate. So this would be 3 minus square root 6i. And on top, I have to keep the same thing, 3 minus square root 6i. Now, foiling this. 2 times 3 will give me 6. 2 times square root 6i, and it's negative, will give me minus 2 square root 6i. Negative square root 2i times 3 will give me minus 3 square root 2i. Negative square root 2 times negative square root 6. I'm going to have plus square root 2 square root 6i. I'm running out of space. All right, those square roots take a lot of space. On the bottom, I've got 3 times 3 is 9. 3 times negative square root 6 gives me a negative 3 square root 6. Negative 3 square root 6i plus 3 square root 6i. Don't assume it. Check it here. Minus square root 6 squared I squared. Square root 6 squared I squared. All right. I see a challenge coming up here. This term is the exact same as that term. So I did my conjugate correctly. My imaginary numbers have disappeared from the bottom because this is -1. So I will have, simplifying here, this is the same as equals 6. Now these are i's and these are i's. So I'm going to factor my i's out so I can start seeing my imaginary unit. So -2, I'm going to say plus -2 square root 6 -3 square root 6 I. All of that is part of my imaginary unit. I can't get rid of any of it. And then I have square root 2 times square root 6. Now, if you think back, you can remember how we used to do square roots. You could do a square root of 12, and that's the square root of 3 times 4, which is the square root of 4 times the square root of 3, which is 2 square root 3. Remember this way that we used to be able to separate? This was how we simplified roots. Now we have to go backwards. We have this, and we have to go backwards. So I can put these under one square root and do 2 times 6. That will give me my 12, which is part of the reason why I went forwards here, so you can see what 12 will become. I squared. And this is positive, so don't forget your plus there. It can get very confusing very quickly. All right, on the bottom I have 9 minus square root 6 squared. Well, the square root and the square go away, and so I'm going to have minus 6. And then this is I squared, so this is going to be times the -1. So it's really going to be 9 plus 6. So we are almost there. I'm going to bring this is my -1, so let me actually change that to a -1. -1, that's what I squared is. And I'm going to bring this, because it's now real, over here. I'm still going to have my large numerator here. So 6 minus square root 12. But what is square root 12? We just did it here. Square root 12 is 2 root 3. 6 minus 2 root 3 plus, and then I have this term in front of my i's, -2 root 6 minus 3 root 2 I. Now be careful. I notice these things, and you're not in my classroom to actually help me. This is how I do tend to work. I knew that this was supposed to be a root 2. It came from here. That's a root 2, root 2. This is a root 2. In my mind, I actually saw this as a 2 and everything until I went to copy it here, and then I realized I had it wrong. So this is why I miss having you guys in my classroom, because I make these mistakes in my own math and I have to rely on others to help me catch them because I don't see them. I literally don't see it. So 9 plus 6 give me 25. Now, it's simplified as much as I can go. However, it is not in the form a plus bi. So I can't be done yet. So I'm going to have to rewrite this, and I'm going to write it as 6 over 25 minus 2 square root 3 over 25. Why is that square root 3 now? Sorry. Another error. This is supposed to be a square root 6. Nope, that is square root 3, sorry. My mind is going crazy here. I saw one of my mistakes. I see them everywhere now. So 6 over square root 25. There's my problem. This is a 15. I knew I was seeing something somewhere. Forgive me here. I'm now going to record the thing with the 15. The 15. I was thinking something completely different. So we've got 15 on the bottom. Now it works. And then I have the plus, and I still need my parentheses. Negative 2 square root 6 over 15 minus 3 square root 2 over 15 I. So, now that I've gotten out of that confusing part, this is why you should have space on your paper, but I ran out of space as I was making this. I now simplify my fractions. This fraction will simplify, and this fraction will simplify. So, dividing by 3, I get 2/5 minus 2 square root 3 over 15 plus, open parentheses. This is my real part right there. That's my real part. This is my imaginary coefficient. Negative 2 square root 6 over 15 minus. These will cancel and will give me a square root 2 over 5. I. And I hope that looks right. It looks like what I solved it as before. All right, there's my answer. And I hope I didn't confuse you too much on that last problem, but you get the idea. We need to multiply by the conjugate. Multiply by the conjugate. FOIL. Group the imaginary and real parts and solve this problem on the bottom so you have a real quantity on the bottom. Then separate into fractions and list in the form simplified fractions of a plus bi. And that is today's lesson. Go ahead and do the homework. Work through some of these problems. I'll see you tomorrow.